situation described presents a significant electrical safety hazard that demands immediate correction. Bundling conductors of various voltage levels and sizes together in a confined space, particularly underground, creates multiple potential problems. Firstly, the presence of 480 volts, 120 volts, 24 volts, and signal wires within the same bundle introduces a risk of voltage induction. Higher voltage conductors can induce a voltage in nearby low voltage conductors, potentially damaging equipment or creating shock hazards. Secondly, the variety of wire sizes, ranging from number 12 to number 0, suggests a wide range of current carrying capacities. When these conductors are bundled together, heat dissipation becomes a major concern. Each conductor generates heat as current flows through it, and the bundled configuration restricts the ability of that heat to dissipate into the surrounding air or soil. This can lead to overheating of the conductors, insulation breakdown, and ultimately, short circuits or even fires, as it seems happened in this instance. Thirdly, the use of wire ties to secure the bundle exacerbates the heat dissipation problem. Wire ties further restrict airflow and create hotspots within the bundle. Additionally, the material of the wire ties themselves may not be rated for the high temperatures that can occur in an overheated conductor bundle. Fourthly, the presence of smoke emanating from the manhole after a breaker reset indicates a severe fault condition. Smoke is a clear sign of burning insulation or other materials, which releases toxic fumes and poses a significant health risk to anyone in the vicinity. The fact that the breaker tripped suggests that a short circuit or overcurrent condition existed, which needs to be thoroughly investigated and corrected. Fifthly, underground environments are often damp or humid, which can further degrade the insulation of electrical conductors over time. Moisture can penetrate through small cracks or imperfections in the insulation, leading to corrosion and electrical leakage. This is especially problematic when conductors of different voltage levels are in close proximity, as the leakage current can create a path for electrical shock. Sixthly, the lack of qualified workers performing electrical installations can lead to numerous errors and safety violations. Unqualified workers may not be familiar with proper wiring practices, conductor sizing, overcurrent protection, and grounding techniques. This can result in substandard installations that are prone to failure and pose a significant safety hazard. Seventhly, the NEC National Electrical Code provides specific guidelines for the installation and support of electrical conductors, including requirements for conductor bundling, spacing, and ampacity dating. It is imperative that all electrical installations comply with the NEC to ensure the safety of personnel and property. Ignoring the NEC can lead to fines, legal liability, and most importantly, serious injuries or fatalities. Eighthly, the mention of long underground runs highlights the importance of proper conductor sizing and voltage drop calculations. As electricity travels through a conductor, it experiences a voltage drop due to the resistance of the wire. If the conductors are not sized appropriately, the voltage drop can be excessive, leading to equipment malfunction or failure. The NEC provides tables and formulas for calculating voltage drop and determining the appropriate conductor size for a given application. Ninthly, the presence of manholes along the underground run creates potential points of entry for water, debris, and other contaminants. Manholes should be properly sealed and maintained to prevent water from entering and damaging the electrical system. Additionally, the manholes should be adequately ventilated to prevent the buildup of flammable gases or toxic fumes. Tenthly, the mixing of 480 volts, 120 volts, and 24 volt circuits in the same bundle without proper separation and identification is a violation of electrical safety standards. Different voltage levels pose different levels of risk, and it is crucial to clearly identify and separate them to prevent accidental contact or confusion. 11thly, proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protector device and preventing electrical shock. All electrical equipment and enclosures should be properly grounded in accordance with the NEC. 12thly, overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices should be properly sized and installed to ensure that they will trip quickly and reliably in the event of a fault. 13thly, the use of separate conduits for different voltage levels is generally recommended to provide physical separation and reduce the risk of voltage induction. However, even with separate conduits, it is important to maintain proper spacing and avoid bundling the conduits together. 14thly, the situation described highlights the importance of regular electrical inspections and maintenance. Electrical systems should be inspected periodically to identify and correct any potential hazards before they lead to accidents. Maintenance should include checking for loose connections, damaged insulation, and proper grounding. 15thly, the fact that the operator reset the breaker after it tripped indicates a lack of understanding of electrical safety principles. Breakers should only be reset after the underlying cause of the trip has been identified and corrected. Repeatedly resetting a breaker without addressing the problem can lead to equipment damage, fire, or electrical shock. 16thly, when separating the conductors into smaller bundles, consider the ampacity dirting factor specified in the NEC Table 310.15b3. These factors account for the reduced heat dissipation capacity of bundled conductors and require that the ampacity of each conductor be reduced accordingly. 17thly, when reconfiguring the wiring in the manhole, use appropriately rated connectors and terminations. Ensure that all connections are tight and secure to prevent overheating and arcing. 18thly, label all conductors clearly and accurately to identify their voltage level, circuit number, and destination. This will help to prevent confusion and errors during future maintenance or troubleshooting. 19thly, document all changes made to the electrical system, including conductor sizes, routing, and termination points. This documentation will be invaluable for future reference and will assist in troubleshooting any problems that may arise. 20thly, consider using cable trays or ladder racks to support the conductors in the manhole. These systems provide an organized and secure way to route and support electrical cables. 21st, ensure that the manhole cover is properly sealed and secure to prevent unauthorized access and to protect the electrical system from the elements. 22ndly, provide adequate lighting inside the manhole to facilitate inspection and maintenance. Use explosion-proof lighting fixtures if there is a risk of flammable gases being present. 23rdly, train all personnel who work in or around electrical systems on basic electrical safety principles. This training should include instruction on hazard recognition, lockout/tagout procedures, and the proper use of personal protective equipment. 24thly, provide appropriate personal protective equipment to all personnel who work on electrical systems. This equipment should include insulated gloves, safety glasses, and arc flash-rated clothing. 25th, develop and implement a comprehensive electrical safety program that includes written procedures, training, and regular audits. This program should be designed to identify and mitigate electrical hazards and to ensure the safety of all personnel. 26. Before starting any electrical work, perform a thorough risk assessment to identify potential hazards and to develop appropriate control measures. This assessment should consider the specific tasks to be performed, the environment in which the work will be performed, and the qualifications of the personnel involved. 27th, use a qualified electrician to perform all electrical work. A qualified electrician has the training, experience, and knowledge necessary to perform electrical work safely and in accordance with the NEC. 28th, if you are not a qualified electrician, do not attempt to perform electrical work. Electrical work is inherently dangerous, and it should only be performed by qualified professionals. 29th, report any electrical hazards to your supervisor or to the appropriate authorities. Do not ignore electrical hazards, as they can lead to serious accidents. 30th, cooperate with any investigations into electrical accidents or incidents. Providing accurate information can help to prevent similar incidents from happening in the future. 31st, learn from past electrical accidents and incidents. By studying past mistakes, you can identify common causes of electrical accidents and take steps to prevent them from happening again. 32nd, stay up to date on the latest electrical safety standards and best practices. The electrical industry is constantly evolving, and it is important to stay informed of the latest changes. 33rd, participate in electrical safety training and education programs. These programs can help you to develop the knowledge and skills necessary to work safely with electricity. 34th, promote a culture of electrical safety in your workplace. Encourage your colleagues to report electrical hazards and to follow safe work practices. 35th, lead by example by always following safe electrical work practices. Your actions can influence the behavior of others and help to create a safer work environment. 36. Remember that electrical safety is everyone's responsibility. By working together, you can create a workplace where everyone is safe from electrical hazards. The resources provided, such as the Occupational Safety and Health Administration, OSHA, the National Electrical Contractors Association, NECA, and the International Brotherhood of Electrical Workers, IBU, are valuable sources of information and assistance. OSHA provides regulations and guidance on workplace safety, including electrical safety. NECA provides training and resources for electrical contractors. The IBU represents electrical workers and advocates for their safety and well-being.